So we just ran through the converse, and the converse is where your hypothesis and your conclusion switch places. So it switches the hypothesis and the conclusion. So P implies Q becomes Q implies P. So let's say that again. P implies Q. If P then Q becomes if Q then P. And when we're looking at the converse, we're asking ourselves the question of, if we have the consequence of Q, can we always conclude that the hypothesis is true? So you'll notice if you look at the converse as it is there, it is actually your biconditional. So the only way for this to work is if, if P is true, then Q is true. And if Q is true, then P is true. So the converse is asking that question. But it's not necessarily going to be true because it is not, they're not logically equivalent to each other. So let's go through some examples again. Okay, so we again have, if there is an accident on the highway, then the traffic will be slow. And we are going to break it up into our hypothesis and our conclusion, or our antecedent and our consequent. So step one, the hypothesis here is after the if statement, there's going to be some information. And then after the then statement will be our conclusion. So our P in this case is going to be, there is an accident on the highway. And our conclusion, our Q, is going to be the traffic will be slow. There we go. The traffic will be slow is going to be our Q, which is our conclusion. So we're going to have if P, then Q. So let's rewrite that again, just to remind you of what it's going to look like. So P, then Q. And the converse is where we switch the order. So we're going to say if Q, then P. Okay. So again, the order there is switched. And the Q comes first in the converse. So if there is an accident on the highway, then the traffic will be slow. We're going to switch those two around. So let's just change will be to is slow to make it make more sense. Then we have there is an accident on the highway, which is the P part. And we're going to move it to the back. And the traffic is slow. We're going to move it to the front. So if the traffic is slow, then there is an accident on the highway. Now, once again, we can think of ways in which this is not necessarily true. So if the traffic is slow, we can once again use the idea that it could be rush hour, or they could just be doing some construction. So it doesn't mean that if the traffic is slow, there is definitely an accident on the highway. So it's not necessarily true. So once again, if P then Q is not logically equivalent to if Q then P. They are not going to have the same truth values in sequence when you go look at your truth table. So let's look at a mathematical example. If a number is divisible by 4, then it is even. So the first thing we're going to do is we're going to break it up into its hypothesis and its conclusion, or its antecedent and its consequent. So a number is divisible by 4. That is going to be its hypothesis. It's divisible by 4. Then it is even. And that is going to be its conclusion. Now you'll notice that I left the number part out because we're going to have to refer to numbers regardless. So it's information we're going to need. So if P, then Q is our standard conditional. And now we are looking at the converse of it. So it's going to be if Q, then P. So let us switch the Q and the P around. So we're going to have it is even, then it is divisible by 4. So we're going to refer to if a number is even, then it is divisible by 4. So we have if a number is even, then it is divisible by 4. And you can see that the P and the Q have switched places. And now we're going to think of an example where this is not necessarily true. So can we think of any numbers that are even, which are not divisible by 4? So I would go for, 2 as an example, or 6. Let's write down 6. Is 6 even? Yes, it is. Is it divisible by 4? It does not give you a whole number, it gives you partial, so therefore it is not divisible by 4. So here is another example where it doesn't hold, so it's not going to be logically equivalent. So there are going to be even numbers which are not divisible by 4. Or multiples of 4, to be more accurate. So once again, if P then Q is not logically equivalent to if Q then P. So keep that in mind, particularly when we're creating our arguments.